Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a very simple problem on finding the resultant of concurrent coplanar forces. So I'll start with only two forces. So determine the resultant of the two forces shown below and specify the angle in standard position. Remember that the resultant of concurrent coplanar forces is a force, therefore it is a vector, so the magnitude as well as the direction must be specified. And in this case, we have to specify the direction in standard position. Standard position from trigonometry counterclockwise. Uh, we measure the angle that the resultant makes with the positive x-axis in counterclockwise direction because that's the positive angle. So we have perpendicular forces. Therefore, by parallelogram law, in this case, the parallelogram reduces to a rectangle. Then we use Pythagoras theorem to solve for the magnitude of the resultant as shown in the figure. So R is square root of the x component of this force, which is already 150. So 150 square plus 80 square. Remember that this is the reverse process from the previous method, previous problems, where we resolve the force into x and y components or u and v components. This time, we do the opposite way, given the components to find the single force or the resultant force. So R is, then this is theta x. R is square root of Rx square plus Ry square. So square root of 150 square plus 80 square because they are perpendicular. So R is 170 newtons. Then tangent theta x is opposite 80 over adjacent 150. So theta x is equal to 28, positive 28.07 degrees, so it is understood counterclockwise. Now for your case, I want you to solve this problem so that although simple, then so that you can uh, you will be happy because I know you can solve this. So show that R is 150 newtons and the angle that R makes with the positive x-axis is 53.13 degrees. So that's it for this problem.